So the background of Broza is really focusing on seat structures, door modules, so interior, exterior, and we also focus on actuators or drives. We are a premium automotive supplier. Key manufacturing challenges that we face are static calculations being king. But the problem with static calculations is that they lead to static results, which production in itself is not a static nature. If we see that we're able to minimize or optimize the bottleneck, we can then reduce the buffer sizes. Because with the planning side, we are able to take all of the isolated planning silos that today happen in a value stream. So you have welding, you have logistics, you have assembly. And with simulation, we're able to connect them all together to see how it truly fits. The real value is showing to, let's say, management, how should the assembly line look from a bird's eye perspective. They can see it on the line and they can maybe assume if I add another pallet or another shuttle to a palletized line, that should have an impact. So we're able to expand the value of plant simulation by using it from the assembly line to operators, but also to entire value streams or even to the plant perspective. There are a lot of different aspects that we can touch to trial out before we implement on the shop floor. A specific use case of plant simulation and doing that type of a time analysis is that we had a palletized line. This plant had an automated station in which the cycle time grew above the plan and ended up becoming the bottleneck. So taking that into this plant simulation, I consider all types of time, the process time, the cyclical time of the operators. So once we see that and then see the impact and the relationship of the times, maybe we should change our attention to that station and address that cycle time. Once you input that into plant simulation, then you bring that to the plant, who is our customer. But once they see that the times and from there, then that gives us, from the simulation perspective, the opportunity to optimize. So then how do we optimize? I can hypothetically give one route all the drop-off locations. I can then take that into the genetic algorithm and give every route, every opportunity to make a drop-off, but then force the algorithm to evolve a certain way based off KPIs that I'm coding into the genetic algorithm to then evolve into a scenario where we make the routes more efficient. The biggest impact of implementing plant simulation into Broza has been efficiency. We're able to see a lot of different things from both the actual to the planning side. With plant simulation, we can identify those gaps early on and help address them to really avoid that future cost that we would end up taking on downstream when we actually hit production. And then we can understand those pain points virtually. So if you have the right mindset, the amount of problems that you can solve are really limitless.